It's a small room, so feel free to stop me, throw things at me, heckle me, love all of these things. It's meant to be a somewhat tongue-in-cheek, back-and-forth session, so please stop me and we'll dive into anywhere you really want to go. So with that in mind, I run a company called Streambased that typically focuses on exposing Kafka and Iceberg data through either Iceberg or Kafka clients. But occasionally we think about AI agents and how they might get access to real-time data as well. So I won't be talking a lot about data storage or things like that, but what I will be talking about is accessing data and primarily via MCP. For the AI guys, I'm sure there's guys that have a lot more AI experience than me. We won't be talking tuning, training LLMs, things like that. We won't be doing anything like that. We're going to this is Data Streaming Summit, so we're going to focus exclusively on getting the data in and utilizing it while it's there. So we're going to talk about a principle I like to call vibe coding for data. That's trademarked. You can't use it. It's mine. And it follows a lot of the principles of vibe coding. If you were to squint a little bit, you could call vibe coding the process of taking someone with an idea or a plan or a product, say a product manager, and using AI to remove a lot of the grunt work that sits in the middle of that. Work that would typically be done by a software engineer. So the result is, instead of having my PM go, I need this, 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 and this, and then the critical part with having that PM not have the skills to be able to achieve that goal. So instead of doing that, he has to communicate it to a person. The person has to go away and develop the product, and that's what we end up with. This is old hat now, right? Everybody knows vibe coding, whether you're a somewhat controversial subject, whether you're a big fan or I don't like it at all, it's here to stay. Why don't we just apply the same processes to, the same thought process to data? In that case, our stakeholder, our person with the requirements would be a executive, somebody who wants to make a strategic decision but doesn't have the data available, or wants to get observability or visibility on a part of the business that hasn't had today. Typically, how would they achieve that now? They go to a data analyst, a data scientist, and for me, it's the same flow. They're going to an expert that has the technical skills in order to be able to solve that problem, and they're generating a report, a dashboard, or something like that that then does it. Why can't we let our agents do that instead? Well, it turns out there's quite a few reasons you can't, especially when you start looking at real-time data. Especially in the real-time world, our typical flow of developing applications is to be very, very rigid about the set of requirements and the set of outputs. Anybody who's had to develop a stream processing pipeline knows that you have to be extremely clear about what's going in and what's coming out in order to make that effective. Agents don't do that. And the very nature of the kind of flow that we're trying to generate is not that. It's a very, very unpredictable query pattern. One day I could be going, how many widgets did we sell today? The next day I go, where should I invest, right? This is completely different problems and completely separated, and something real-time data isn't typically very, very good at solving. However, if we can get past that, we get some bonuses. We get absolute fresh data. You don't want to make decisions on old data. And you also, potentially, this is going to refer back to a slide at the end, you potentially get authoritative data because you get a full view right from the very last millisecond all the way back to the beginning of time, depending on which way you do it. The other thing, so that's the nice things to do, but you get some challenges as well. One of the big ones, any schema registry users here? Wow, that's the first room I've had no one actually using schema. You guys should be ashamed of yourselves. If you're, let's assume one of you is using schema registry, the next question was going to be, how many comments do you put on your schemas? The answer is none, right? They're just magic data. And that's okay because our data analyst or data scientist has done this for your organization for years, knows what everything is, and has a much wider context. If you're going to try and point an agent at it, you have to give them a much, much better idea of how the data is structured and where they're looking. And you also, this one's kind of like a side note. on that same note that while your data scientist understands the structure of the data, it also understands the multiple data sources and how they interact with each other. And that's in a way that an agent might not. So if you're sitting there and going, I have an MCP server that connects me into Snowflake, I have an MCP server that connects me into Kafka, where do the bounds at which those cross over and how they can be used together is super unclear for people, so doubly so for any agent that you might point at the problem. Before we go on, I'm going to address the elephant in the room. We've talked about unpredictable query patterns, short point lookups, analytical, very, very analytical queries, and somebody normally at this point sticks their hands up and goes, wait, that's not what we use Kafka for. That's what we use a database for, right? Well, if I've been doing things with Kafka for the last decade, and if I had a penny for every time somebody told me that's not what Kafka's for, and then we went and built a KIP and did all of that stuff, then that's what the nature of it is. It's an evolving project, and as such, it's evolving in the ways of to start eating up the analytical world and to start addressing these kind of problems. To give you an example, when I started doing Kafka, Kafka was a message bus. And we said, when we started talking about doing some processing in the middle, they were like, whoa, that's not what Kafka's for. Kafka's for getting data from A to B. Right? We're in a world where we're storing long-term analytical style data into Kafka. This slide's actually out of date. KIP 1150 added long-term storage, cheap object storage. Well, KIP 405 added that. KIP 1150 adds the kind of cheap object storage you can write directly to. And there's actually now another one where we're starting to add native iceberg support into Kafka. We wouldn't be doing this unless Kafka was evolving to take on these more analytical workloads. And there's a bunch of companies, including Streambased, that addresses these kind of problems. So back to today. I haven't got much time with you, so we're going to do things very quickly. We're going to create a very simple version of data access via MCP. Anybody here used MCP servers before? Thank God. There's actually some hands going up. Okay. MCP was developed over at Anthropic. It gives agents a way to interact with external systems and tooling. What I think is a shame, and this is the point where you start throwing things at me, what I think is a shame is that everybody just jumped from MCP to automation. So the typical set of MCP tools either create pipelines or they go ahead and send emails or things like that. I feel like there's a lot missing in terms of just raw data access. Why can't we just go and fetch data with MCP? To give you an idea, the most prominent MCP client for Kafka is probably the MCP server for Kafka is probably the Confluent one. Can't actually fetch any data out of Kafka with that. What you can do is you can create a Flink job, or you can create a consumer group, or you can do things like that. But I feel like, oh, by the way, if you do want to do any of that stuff, you have to know already how to do it, because it's way complicated. But I feel like there's something missing in the ability to just interact with data directly via natural language. And so that's what we're going to do today. It's a very simple MCP server, and it's going to go ahead and it's going to expose two tools. The tools are the unit of interaction with your agent, and we're going to have one called getSchema that returns topic info from Kafka, and we're going to have one called runQuery that runs a SQL query that's going to run out over Kafka. And I'm going to show you that just with these tools, you can solve a whole load of problems without having to use your data analyst or anything. On a quick note, well, I won't spend any time on it because it's a different talk, but you'll see we've got Kafka and we've got an index box here. The index is what makes these kind of analytical style queries fast on Kafka. Without it, every single query boils down to start at the beginning of a topic, read to the end of the topic, and drop any information. And it doesn't. The index is what makes this interactive. Let's say that. So I'm going to give you the description before we jump right in. I shouldn't really do this. I should do this at the end. But today we're going to detect some fraud, and we're going to do it via MCP. This is a real fraud borrowed from some of the largest tech companies in the world. Turns out if you just submit an invoice to them that doesn't match anything you sold them, they might actually just pay it. I don't believe that was it really 100 million? Right, so but apparently between 2013 and 2015, Facebook and Google paid out $100 million this way. Imagine if a business-style person had the ability to investigate the data via AI-powered, could have caught that quite easily on the train on the way home. Okay. So we're going to use an AI assistant to catch instances of this kind of fraud. And hopefully, I won't need the next 4 slides. We're going to do it live, but I do have it recorded if we don't need it. So let's start with some Kafka data. This is a very simple, can you all see that all right? That works, yeah. This is a very simple setup. We're going to be modeling a logistics pipeline. My company, Megacorp or whatever, has a bunch of shipments that come in. We then receive invoices for those shipments, and then we pay them. There should be a one-to-one relationship. But all you need to really think about is that our shipments topic and our invoice topics, these are the dynamic ones. So if I go and look, refresh this a minute, that number should go up, and it does, and the shipments number goes up. Around this, we have some reference topics. They're very small, and they're storing sort of employee information, what actually went into the shipment, and what actually went into the invoice, and some information about suppliers. They just enrich it. You may have a streaming application or something like that that is flowing all of these topics together and then landing them into a database or something like that. We're going to go directly onto the Kafka data. And we're going to do it using our MCP client. Now, I made this MCP client. They're very, very nice and easy to knock up, but you could be using Claude, you could be using Copilot. It's just this one looks a lot better on a massive screen. And the first question we're going to ask it, though this might be the most unrealistic part of this exercise, is what kind of data can I query? Probably likely that a business user would skip this step. He's in the business, he knows what it does, so we'd ask it a different way. But I just want to show you the interaction between Kafka and the AI agent. So as you can see, what we've got here is the same topics that we've just viewed, but they're now appearing as if they were, I don't want to say tables, because they're really sort of blobs that we can then interact with as an agent. And I don't know whether you saw it, but the last one was shipments. This is all driven by schema registry, by the way. And just in case you don't believe that they're coming directly from Kafka, we've got some Kafka-style metadata stuck in the end. We got a partition and a So the final thing that we need to do on proving out the data is prove that it's actually real-time. Are we actually up to date on this? So, and we can do this fairly easily. We go look, 2,058 invoices, and we'll do our first sort of interactive thing and say, how many invoices are there? So at this point, we're using the LLM to go ahead and map our natural language into a SQL query, a very simple SQL query, and it's going, fetching the data and giving it back to us. Nice and easy, does it? So, and we got 2,072, which is bigger than the number I said before, so you can see that this is constantly being updated, and we're working with the very latest data set that we have. So if I was my business user, I'm sitting there on the train on the way home, question I might ask my agent is something like, what was the invoice total? Yeah, seems reasonable. I'm just finishing my day. I might want to go and say that. And this is an early entry point into the system because I think most people in the world know enough SQL or know how to use tools to be able to find this problem. But we can do it, and it's nice and easy. And I can ask the same, what was the total shipment value? All right, same thing. Nice and easy, we're getting away. By the way, this is debug mode. You're seeing the SQL that's going along. Normally, you just see the end, right? But right away, we've noticed a discrepancy. If my business was a discrepancy that doesn't fit on the screen, if my business was functioning correctly, these should be one-to-one, or very, very close. But there's quite a significant discrepancy between them. The first thing I might want to do is make everybody aware of it. And I'm just going to show you the power of using multiple MCP tools together by saying, I might want to generate a bar graph and send that off to the support team. Why not? So make me a bar chart that shows what we've ended up here is we've got a really nice context window that's sitting in our agent. You'll notice it's not going back and fetching the data from Kafka to do this. It already has it. It knows that it's got it in the context window, and it's making me a nice bar chart, and I can send that, or I could even use like an MCP to send that over to my support team and ask what's going on. But I don't want to do that. I want to be proactive. Let's go a little bit further. Next thing we need is a hypothesis, right? We need some kind of theory as to what's going on with this. Any suggestions? This is the scary part of the talk where you tell me what to type and all hell breaks loose. Sorry? That's a really good one. Unfortunately, this isn't time-based. I didn't bother. I just put a big chunk of data in. What's the next thing? What would you look for if you were looking for something suspicious? Suspicious bit of paperwork. Count by employee? Which one? Invoice or shipments? Okay. I've never run this before. Let's see what happens. After this, we'll return to normal service, but yeah, we're going to run a query, and wow, we got a lot. So, unfortunately, I don't think that's going to be all that useful to me. So, but that's fine, right? That's why we're here. We're here to experiment with the data. This is the part of vibe coding where you go, make me a website, and it puts everything in a weird corner, and it all looks weird. And you go, wow, I'm going to sit here for another 1,000 prompts until it works the way I want it to. I'll take the next one, and I'll ask, maybe, are there any unusually large amounts? Right? Anything unusual? Right? Are there any invoices with unusually large amounts? Spoiler alert, I bet there is. But what's interesting about it is look at the SQL that's going here. Right? We are now beyond the level that a business user can run. So we're now getting into the realm, like 2 standard deviations away from, like, I don't know, I don't think a marketing manager is really going to be pushing those kind of queries down. So we've already done more than we would be able to do if we had like our non-AI enriched capability. And sure enough, we found out that there are a few invoices with unusually large amounts. So let's try the first one. So every invoice should have a corresponding shipment, so we can go ahead and we can start investigating. Okay. So say, show me the shipment for order 1045. Okay. Because unusually large invoice must have been a very large shipment or some weird or very fancy widgets that are coming through it. So we go ahead and run this, and straight away we've seen our problem. The agents come back and they says, there's no shipments associated with order 1045, this is probably fraud. Right? Great, I could shut the laptop and walk away now, but I think we can take it a step further and say, the next thing we want to do is find out the scope of our fraud. So, are there any other invoices that don't have corresponding shipments? Very simple question, right? If you look at the SQL that you have to run to do that, there's no way my marketing manager's he's going to be way out of his depth now, right? So, we're doing, we've got sub-selects and we've got this guy's not going to find it. And you can probably already see where this is going, but what we have is we have a list of orders that don't have corresponding shipments, and there's one thing that's consistent about all of them. Oh, employee ID. Oh dear. So we can say, look, who authorized those invoices? And what do you know? It's going to come back, and hopefully, it'll give me some more details about that employee. He says. Yeah, he's already running. Well, anyway, let's try again. I think it might be feeling rough. No, let's try it 2 ways. But I can skip this over for you and say what it was about to tell me was that there was an employee named Mr. Crook who was vastly, vastly underpaid for what he did. And so he was he was propping up his income by authorizing fraudulent invoices. But we've done all of that without needing any help from anybody else. We've all done it all with our AI power. So that would be the end of the talk. But obviously, because you guys don't trust me, I definitely cheated. Right? And this is kind of the most important bit. You should always cheat to do this kind of stuff. So first things first, how we cheated, tool descriptions. The MCP standard dictates that you can provide a description. Most of the time, these are just like Git comments. They should be really, really detailed analysis of what you did and what there's. Actually, it's like, work in progress, merge me, please. Right? That's normally what they say. So in this case, we gave it a good chunk of text that said, this is the kind of SQL that you can run. These are the kind of things that I don't want you to do. Look out for these kind of catches. So we got a whole load of, and we even down to the fact that you can say schemas are mutable. Go check. Are we running with the latest schema for our data and things like that? So you can give a lot of prompts in that way. There's just one problem with this that I encountered while testing this. These go in the context window. So when they start getting really, really large and you start having a lot of tools, then you can cause yourself a lot of problems. So the larger the better within reason is the way to go on that one. The other way we cheated, we mentioned this before, but we can do the same thing with our schemas. This is coming from schema registry. So for every single field that we came across, we gave a really detailed description, including the relationships with other fields. And the most important line on this slide is the last one. This isn't just an AI thing. Do your schemas nicely. Schemas are good. In fact, for this group, go use schema registry. So that's how we cheated. There's a few things, and the last couple of slides are about what I'd like to see in the world, where we're not quite there yet, and we're having to do really horrible workarounds. You'll note that in this example, pretty much every prompt that I put returned a very small volume of data. That's because you really don't want to turn your agent into the conduit for data. You can imagine that if I had a fully fledged Kafka, I could easily ask for billions of rows back. And then let's say I wanted those rows to be realized as a chart in a dashboarding tool, something like Superset. What I would be doing is flowing all of that data through the agent to the other one. So I would like to see like a categorization. I'll tell you a little trick here, by the way. Agents in this love naming conventions. So to solve this exact problem, I did it by accident the first time I did this. What you can do is I can create a database named Streambased in Superset, right? And I create an MCP tool named Streambased for accessing my Kafka. I can then work interactively with Streambased by saying, use Streambased to go and find me the top 5 whatevers. Right? And then I can say, use Superset to graph me the top 5 whatevers from Streambased. The agent will interpret my queries against the Streambased tool, but Superset will interpret my queries against the Streambased database. So you get, and at that point, you're doing this path. You're doing the link outside the agent down in Superset. But you shouldn't have to. In my perfect world, I'd have tool categorization that says, here's how to achieve this for interactive, in an interactive way, and here's how to achieve it in an automation way when I'm producing a static output product. Hopefully we'll get it one day, soon. And finally, just going back to what we talked about previously about the nature of Kafka changing, I lean towards the real-time side of things because I think we're going to see a world where real-time stretches longer rather than a world where the more longer-term stores, your traditional OLAP start stretching in. So what would be really nice for this example, what would be really nice for our MCP tools would be to be able to address a consistent data set. Us is great, by the way. That goes all the way across from like our hot set storage in Kafka or something like that, all the way through our longer term cold set storage. So what have we done today? It's a very brief example to show that, and the goal being that to show that MCP is not just for automation. We can interact with our data, and we can do vibe stuff. Like vibe coding isn't just for developing software. Let's do vibe coding with data as well. But there needs to be guardrails. There's a lot of work that's done before. We want to have detailed schemas. We want to have detailed tool descriptions to say what we want to do. But all of this work also helps your larger data estates. It's a great idea to do anyway. And finally, simplicity is king. The less sources you can connect, so that's kind of a misnomer. So it's not the less sources you connect, it's where you can push down the federation point. So for instance, I love things like Trino, so where you can have a federation layer that sits above, and that's the thing that interacts with your agent, and then all of your data sources are down there, so that you don't have to make the agent aware of every different type of data that can go. I don't believe that's the agent's responsibility. So with that, I'll say thanks very much and invite questions, straight throwing stuff. Any questions? Oh.
The cheat that you used, for your use case, you can describe that maybe like 100 lines or something, but for an enterprise, let's say where you have a whole bunch of different use cases, do you imagine there's a file of like thousands of lines of all these descriptions, SQL examples and stuff, or do you feel like maybe that's the quote-unquote hack today, but where AI is going, we won't need that as much in the future once the training is more accurate or something?
Both. So I do imagine there's some very, very large, I liken them to system prompts, where you got like, there are some very, very large and very, very detailed ones that are floating around. Weird aside, I actually got ChatGPT to write that one. I said, go look at the docs and write me a system prompt, and that's what it did. And it was pretty good. Where I think it'll go in the future, I don't necessarily think we need to solve it via training. I think multi-agent systems do a pretty good job of this. So you would have, instead of having a massive long catch-all tool description, you would have an agent that's associated with that tool, and they would orchestrate together in order to solve it. Yeah, exactly. Yeah.
Yeah, so how are you able to kind of deal with like false positives and
So in this example, and to be honest, in real life, the largest chunk of that is in good data governance. The better you can describe the data and the better you can you have it, the more accurate you will be. However, the same rules always apply. It's only as good as your human equivalent. So how do we put this? I would say these are really good for investigations and interactions in the kind of way that we did. If you wanted to use it for critical decision making, you should probably have a longer think.
Question on the flow diagram. What was the use of index in there? Like, because you have the LLM basically querying in the form of SQL, so it's translating text to SQL. But is indexing helping anywhere there, or?
Yeah, so in this case, the data set's probably too small for it to kick in. However, the problem with running SQL on Kafka today is that everything boils down to seek to offset 0, read, does it match my query, drop messages, things like that. So this is a Streambased thing, a different talk. But we've developed an indexing technology that sits on top of Kafka and allows these kind of point lookup, small volume return queries to become efficient.
So the SQL is actually hitting the index technical,
Yes,
right?
yeah.
Oh, got it.
So the index in this point maps, you interpret the SQL query, and we map down to ranges of offsets that are relevant and skip a lot of reading.
Oh, yeah.
We're good?